Welcome back to the NPTEL course on mechanical and electrical systems of mining machines. Today we will be doing lecture number 23, that is the tutorial on shovels, which is a part of module 2, that is mechanical systems in HEMM. HEMM is heavy earth moving machineries. So the concepts that would be covered in this tutorial would be the two questions on shovel. We will be learning about how to determine the capacity of the shovel. Well, just to give you a brief of how do we calculate the capacity of a shovel. So let me explain you the basics of how we calculate the shovel capacity. So when we talk about shovel capacity, it is given as Q is equal to B multiplied with F multiplied with U by T multiplied with SF, and the unit is meter cube per second. So what is B? B is the bucket capacity, that is in cubic meters, and F is the bucket fill factor. So if you remember what is the fill factor and swell factor from the first class, so you would understand what is a bucket fill factor. Now let me explain you again. Now the bucket has some inner volume. Now when it does the cutting operation, some part of the bucket gets filled and some other part remains unfilled. So the amount of material that gets filled inside the bucket divided by the total inner volume of the bucket gives you the bucket fill factor. So it is always less than 1. Now if we tell about the bucket fill factor as a thumb rule for shovel, it ranges from 65% to 75%. If it is not given in the question, you may assume this as the fill factor of the bucket for shovels. For details of this, you may again go through the overview slide, that is the lecture number 1 and 2. There you will be able to know what is the bucket fill factor. Then what is U? U is the shovel utilization factor. Now there is 24 hours. In 24 hours, only 16 hours is utilized. So that gives you the shovel utilization factor. Again, it is a fraction. Now when we talk about the shovel cycle time, it is given by this unit T, and this shovel cycle time is in seconds. So how much, for how much duration the shovel has operated is given by this shovel cycle time. Now again coming to another factor, which is the swell factor or rock loosening factor. Now in the virgin state or undisturbed state, the rock would be having certain volume. Now when you disturb it, it expands. You cannot fill it into the same crater or the pit that you have digged in, because its volume has expanded. As the grain size changes, the orientation changes, so they cannot be packed the way they were originally packed in its virgin or undisturbed state. So that factor we call it as a swell factor. So the volume of the material in its disturbed state by the volume of the material in its undisturbed state give us the swell factor. Now this swell factor is always greater than 1. Now the shovel capacity that we have discussed here is in unit meter cube per second. Well, when we have to determine the shovel capacity on hourly basis, that is meter cube per hour, we have to multiply 3600 in the numerator to convert it into hourly basis. Now when there is a term called as a technical factor, okay, so there is a term called as technical factor, which is KT. So this technical factor depends on how big your boulder or how big your chip size is, or how big or your cut material is. Let's say when you are excavating, so it all depends on what should be your speed and what should be your penetration forces that you are putting into and what kind of rock it is, if it is a very fragile, friable rock, or if it is a very hard rock. So it all depends, the technical capacity depends on the kind of the boulder size or the rock size that this shovel would excavate, and that would give you a factor called as KT. That is generally, there is a table for the technical factor that you may find from various sources, which is dependent on the average diameter of these boulders that are excavated, or else you may assume it as something like 0.4 to 0.6 to calculate the shovel capacity. Again, if it has to be given in the unit meter cube per hour, or if not, if the shovel capacity has to be stated in hourly basis, then this factor or this number 3600 has to be multiplied in the numerator. Now, how do we know what is the production cost per unit of the material that is excavated by a shovel? Well, there is a formula which gives us the total production cost, which is the fixed cost plus the variable cost. Now, when we talk about this total production cost with fixed cost, there is a term called EMI that has to be given for while, let's say if we have not given the upfront, we have not paid upfront the value of the machine, then a EMI has to be given every month, which goes as a fixed cost. Then there is a depreciation cost, and there is this interest that has to be added, and there is insurance cost which has to be added to give the fixed cost. Now, there is a variable cost. When we talk about variable cost, we have the salary of the manpower, then we have the energy cost of the shovel, and then there is the cost for the lubrication of the shovel per month, and then there is a repair cost. So, these are the variable cost, so which gets added up to and gives us the total production cost. Now, coming to the production cost per unit of the material that is excavated by a shovel. So, how do we find the production cost? The production cost is fixed cost plus the variable cost. Now, in the total production cost, there is the EMI of the machine that is bought, then there is the depreciation cost of the shovel per month, and then there is the insurance cost of the shovel per month. So, the EMI is to be given monthly. So, this is accounted in its fixed cost. Now, in variable cost, it accounts for the salary of the manpower that is engaged per month. Let us say we have less manpower in a month, then my salary again goes down. So, that is why it is in a variable cost. Then we have the energy cost of the shovel, that is either the fuel cost or the power cost per month. Then we have the lubrication cost of shovel per month, and then there is a repair cost of the shovel per month. So, which accounts for the variable cost. Now, there is the production cost per unit. How do we find that? We have to take the total production cost per year divided by the total production per year. So, this gives us the production cost per unit. Now, in this fixed cost, there is a EMI component. So, how do we find the EMI? So, let us say we are assuming 0 salvage value at the end of the life and depreciation that follow a straight line. Now, how do we find the production cost per unit of material excavated by the shovel? So, there we find the total production cost, which is the fixed cost. So, now how do we find the production cost per unit of the material that is excavated by the shovel? So, that is total production cost, that is the fixed cost plus the variable cost. Now, when we talk about this fixed cost, it accounts for the EMI that is given for the while we have purchased this shovel. So, it cost huge amount. So, it cannot, if it is not given upfront by the buyer, then it has to be divided into monthly installments. So, that accounts for its fixed cost. Then there is the depreciation of this machine, and then also the insurance cost, which accounts for the fixed cost, and this fixed cost is calculated on monthly basis. Now, in variable cost, there is a salary component of the manpower engaged. Let us say we have engaged lesser manpower, then the salary cost will be less, and if we have engaged higher manpower in a month, then the salary cost will goes high, and onto that is dependent on the energy that is spent by the or used by the shovel. So, that leads to the energy cost, that is in form of fuel cost or the power cost per month. So, if it is electric, there will be power cost. If it is by fuel or it is diesel driven, so then it is the fuel cost. Then there is the lubrication cost of this shovel per month, which is very much necessary for smooth operation of this machine. Then there is the repair cost. Well, when we talk about all these costs, that is salary, energy cost of the shovel, lubrication cost and repair, it accounts for the variable cost. So, total fixed cost and the variable cost gives us the total production cost per month. Now, how do we find this value EMI that is accounted in the fixed cost? So, let us say we assume 0 salvage value at the end of the life and depreciation follow a straight line method, then we get the EMI as purchase price plus purchase price multiplied with the interest multiplied with the estimated life of this machine, that is the shovel, divided by 12 multiplied with the estimated life of the shovel, which is in terms of, like this gives me in terms of month. So, every monthly what would be my EMI. So, this purchase price plus purchase price multiplied with interest multiplied with estimated life of shovel gives me the total amount that has to be paid, which is divided by the estimated life of the shovel, and which is again divided by the number of to convert it into for years to be converted to monthly basis, it is divided by 12, which gives me this formula for EMI. Now, when I talk about the production cost per unit, what is it? It is total production cost per year by the total production per year. Now, total production cost we could find with this formula, and the total production per year we can find with Q year. So, this Q year we can find out using this formula, which is on hourly basis. We have to convert it into yearly basis, then only we get this Q year. Now, coming to the problem that we need to solve for shovel. So, where we have the first tutorial question, as a shovel having bucket capacity of 4.6 cubic meter. So, the bucket capacity is 4.6 cubic meter, operates in an iron ore mine with the following conditions. So, what is it? The shovel cycle time is 23 seconds. So, what is the shovel cycle time? That it digs onto the virgin rock, retracts it, and then moves around, dump it onto the dump truck, and then return to the same position. So, this complete is the shovel cycle time. Then the utilization factor, which is 75% it is utilized. The bucket fill factor is given as 0.85 and the swell factor is given by as 1.25. The shovel operates 2 shifts per day and the working days per year is given as 350. Now what do we have to calculate? Calculate the yearly capacity of the shovel. So what we have to calculate? Yearly capacity of the shovel. So if bulk density of material is 1.7 ton per meter cube. Now how do we find the solution? So what do we know? We know that my shovel capacity per hour is given by QH is equal to 3600 multiplied with B multiplied with F multiplied with U by fill factor, utilization factor, shovel cycle time multiplied with swell factor, right. So the capacity per year, so first let us see what is the hourly basis. So this is 3600 multiplied with what is my bucket capacity, it is 4.6 multiplied with 0.85 multiplied with 0.75 divided by what is the time? The time is 23 seconds multiplied with 1.25. So this is my capacity for hourly basis. Let us say it operates 2 shifts a day. So per shift, per shift is 8 hours. So we multiply 8 multiplied with 2. So this is per day shovel capacity. So this gives me per day. Now yearly is multiplied with 350. Now the bulk density has been given as 1.7 ton per meter cube. So if we find it as we multiply 1.7 here to find the answer. So here we are getting it as meter cube per year. So if we multiply this, so this gives me ton per meter cube. So meter cube cancel. So this my unit is now ton per year. So my answer here is around 3.5 into 10 to the power 6 ton per year. So this is how we solve for the shovel capacity. Now coming to a different kind of question on the shovel, where we have to calculate the production capacity per hour as we have solved for the last question. Along with that, we will calculate the production cost per hour and the cost per ton of material per hour. So what is this question? This question gives the particular that refers to a electrical shovel whose capacity is 4.6 cubic meter. Its average life it is given as 20,000 hours or 10 years. The power is 500 kVA that is utilized per month and then or per hour, and then there is a lubrication cost that is 12% of the power cost. The repair case cost is 60% of the depreciation cost. The cycle time is 38 seconds. Bucket fill factor is 0.75. Purchase price is rupees 6 crores and the salary of manpower engaged is rupees 65,000 per month, bank interest is 15% and insurance is 10% of the purchase price per year. Now, it is what is asked in the question is calculate the production capacity per hour, where the utilization factor is 0.88, which is 88%. Now, find the production cost per hour is the second question, and find the cost per ton of material if bulk density is 1.77 cubic meter. Now, how do we solve this question? So, first we have to find the production capacity per hour. The production capacity per hour, which is given by QH is equal to 3600 multiplied with B multiplied with F, that is the fill factor, multiplied with U, that is the utilization factor, divided by T into SF, right. So, how do we find it? It is equal to 3600 multiplied with V. B is given as 4.6 cubic meter multiplied with fill factor, which is given as 0.75, and utilization factor is given as 0.88, divided by 38 multiplied with SF. So, let us say SF here is SF is equal to 1. Okay. So, this gives me my production capacity per hour as 287.62 cubic meter per hour. So, this is my first answer, right, which asks me calculate the production capacity per hour if utilization is 88%, that is the utilization factor is 0.88. Now, what I have to find, that find the production cost per hour. So, the total production cost per hour, how do we find out? We find it as fixed cost plus variable cost, right. So, with fixed cost we have to find EMI plus the depreciation plus the insurance cost plus what is my variable cost? It is salary plus energy cost plus lubrication cost plus repair. Now, my EMI, this is in monthly basis, right. So, what is asked in the question is per hour. So, I have to calculate this complete in hourly basis. So, first if we find the EMI, or rather I would say EHI, that is equal hourly installments. So, how do we find it? That is purchase price multiplied with 1 plus interest with the life multiplied with the life of the machine divided by 12, that gives me the monthly basis, right. If I want hourly basis, so I have to multiply the number of days, that is 30, multiplied with number of hours, that is 24. So, I find it as, what is the purchase price? This is 6 crores. So, gives me 7 zeros multiplied with 1 plus I into number of L is the life of the machine in number of years. So, that is here instead of I, let me write 0.15, that is the interest, 15% is the interest, multiplied with the life, that is in number of years, that is 10 years, divided by 12 into 30 into 24. So, it gives me, and then divided by the number of years again, because this is per month, per day, per hour, and then in how many years? It is in 10 years. So, this gives me rupees 1736 per hour. Now, when we count the depreciation on hourly basis, so here nothing has been given in the question on the depreciation. So, I take it as the cost of the machine, that is 6 crores divided by number of in months, then in day, hourly, and how many years, that is 10 years. So, this gives me as 694 per hour. These are approximate values, there are some points after that. Then we find the insurance value. So, and that to be on hourly basis. So, when we find the insurance value, what it is given? It is given as 10% of purchase price per year. So, what the purchase price is 6 crores. So, if I write 6 crores here, it is 6 crores per year multiplied with 0.1 divided by, this is for per year, then per month we divided by 12, then per day by 30 and per hour by 24. So, this gives me again the same value as 694 per hour. You may calculate it. So, this accounts for my fixed cost. So, here total production cost per hour, the fixed cost component comes from here. Now, coming to the variable cost. In variable cost, the first is the salary of the manpower per month, which is around rupees 65,000 per month. So, per day I have to divide it by 30 and then per hour by 24, which gives me rupees 90.27 per hour. Well, when we talk about the energy cost, it has been given that the power that is supplied to this machine is 500 kVA. So, for this 500 kilovolt ampere, so how do we find? Let us consider that rupees 5 is charged for per hour. So, for 500 kVA it is around 2500 per hour. Now, for lubrication cost, my lubrication cost is 12%. It is how much is given? It is 12% of the power cost. So, this is 0.12 multiplied with 2500, which is equal to rupees 300 per hour. The last one is the repair cost. So, repair cost is given as 60% of the depreciation cost. So, 0.6 multiplied with depreciation cost is 694 per hour. So, which is equal to now rupees 41.64 per hour. So, this is now my variable cost. So, my total cost per production per hour will be equal to EHI. First is EHI is rupees 1736 plus my depreciation cost is 694 plus my insurance cost is 694 again, plus salary cost is rupees 90.27 plus the energy cost is rupees 2500 plus the lubrication cost is rupees 300 plus rupees 41.64 is for the repair cost. So, which accounts to rupees 60,055 0.71 per hour. Now, when we have to find the cost per ton, this is equal to rupees 6055.71 per hour divided by the production capacity per hour, which is 287.62 cubic meter by per hour. Let us say we want to find it in tons as is asked in the question. So, we have to multiply the density, bulk density of the material, that is 1.77 ton per cubic meter. So, cubic meter got cancelled, hour gets cancelled. So, the answer is now 12.38 per ton. So, this is the cost per ton, which is my answer C. So, this is my answer B. So, this is how we solve the problems when the production cost and capacity of the shovel is asked in the question to be calculated. Now, you can refer these books for solving problems and for understanding the concepts for this part. Thank you.